Okay, to wrap up this unit, we're going to talk about applications of relations and functions. So we're going to take all of the things that we've learned this unit and we're going to put them together in application problems. So the first type of problem that you might see relating to this idea of slope and graphs and coordinate planes is this one. Which rule best represents the graphs below? So we're given an equation of a line on a coordinate plane, and then the options that we have to choose from are 4 equations or 4 rules in slope-intercept form. So if you remember from our section on slope, we talked about slope as being our m, which is also called our rise over our run. And we also talked about this thing called a y-intercept, which is where our graph crosses our y-axis. So let's go ahead and use what we learned there to figure out the rule for this line. So let's go ahead and choose 2 points on our line. I'm going to go ahead and choose this point right here. And I'm going to go ahead and choose this point right here. And remember, I have to use my Pac-Man. So if I'm getting from A to B, I need to go up 3. That's my rise. And I need to run 1, which is my run. So 3 over 1 is 3. And my y-intercept is where my graph crosses my y-axis, which is going to be right here. So my y-intercept is 2. So I need to figure out which one of these rules down below represents an equation with a slope of 3 and a y-intercept of 2. So if I put this into slope-intercept form, I have y equals 3x plus 2. And you can see that that matches up with the rule letter 3. And that's how you solve this type of application problem. Let's try another one just like it. I have my graph of my line. So I'm going to go ahead and choose 2 points on my line. I'm just going to go ahead and choose this one and this one. Call him A and call him B. And again, my slope is my rise over my run. So I'm going to rise up 1 and I'm going to run 2. So I have a slope of 1/2. My y-intercept is where my graph crosses my y-axis, which is -3 in our case. So my y-intercept, or B, is going to be -3. So if I put this in slope-intercept form, I have y equals 1/2 x minus 3. Which corresponds with letter D. Okay. The next type of application problem that we have here gives us a rule, and it asks us which table contains only values that make the following true. So we're looking for basically the correct table of value that matches up with our rule. So if you remember from our relations and functions section, we talked about where we choose the x values, the input, and we get out a y value, an output. So we want to figure out which of these, when we put in these specific x inputs, which y outputs are we going to get. Now, this could be a daunting question, but personally, this is how I like to begin. I like to begin by finding an x value that is common. For example, you can see that I have a 1 and a 1 in A and B. So I'm going to use that as my first test point. I'm going to go ahead and say, okay, y equals 2. I'm going to place the x value. I'm going to substitute it in for x, and then I'm going to add 7. So that would give me y equals 2 plus 7, which would give me 9. Well, you'll notice both tables give me a 9 as an output. So that's not going to be the best place to start. So we have to kind of continue this process to figure out what is the corresponding value. So let's go ahead and choose another value that's common. Let's go ahead and choose 0. Notice I have a 0 in A, C, and D. Let's go ahead and try this one. So I have y equals 2. I'm going to substitute a 0 in for x, plus 7. 2 times 0 is 0, so I'm going to be left with y equals 7. So with an input of 0, I have an output of 7. Well, notice that I do have that in A, but I don't have that in C or D. So because that output doesn't match my input, C and D don't work anymore. See how I've eliminated two of my options just by one coordinate? Okay, let's try another one. Now, since 0, 7 and 1, 9 work in A, let's go ahead and try 2 and 11. Let's just try it to see if it works. So I'm going to go ahead and try a 2. So I'm going to say y equals 2 times 2 plus 7. So that's going to give me y equals 4 plus 7. And that's going to give me 11. 4 plus 7 is 11. And see how I have an 11? Therefore, A is my correct answer because all 3 points match up to this rule. Now, just for fun, let's just go ahead and see why B doesn't work. So I'm going to work here along the side. Let's go ahead and look at 3. I'm going to substitute a 3 in there. So I'm going to say y equals 2 times 3 plus 7. So y equals 6 plus 7. And you can see that 6 plus 7, that's going to be 13. So that's not going to work. So automatically, I don't even need to look at 5 and 10. Since 3 and 6 don't work, B cannot be an answer choice. But you do want to make sure that you check everything to make sure every single, you account for each one of these table of values. But in our case, A is going to be the corresponding table of values to our rule. Okay, let's look at another one just like this. Okay, so what we have here, there we go, y equals negative 3x minus 4. Let's go ahead and look for a coordinate that is similar within here. So I noticed that there's a 6 and there's a 6. So let's go ahead and test 6 as my input value. So I have y equals negative 3 times 6 minus 4. And if I simplify that down, that gives me negative 18 minus 4. Yikes. Now, negative 18 minus 4, that's going to give me negative 22, which is neither of my output values. So right off the bat, I eliminated A and B. Now let's go ahead and look at C and D. Do we have anything common between them? We really don't. So let's just go ahead and start with one. Let's go ahead and look at C. I'm going to go ahead and look at, I'm going to start with 0 because I like working with 0. So I'm going to substitute 0 in there. Y equals negative 3 times 0 minus 4. So y equals negative 3 times 0 is 0 minus 4 is negative 4, which corresponds. So that checks in. Let's check negative 1. I have y equals negative 3 times negative 1 minus 4. So negative 3 times negative 1 is 3. If I subtract 4, that gives me negative 1, which matches as well. We might have a match here. Let's test the last one. Let's just test negative 2. Y equals negative 3 times negative 2 minus 4. That gives me 6 minus 4, which gives me 2. So it looks like C is our answer choice, but let's just go ahead and see why D is not our answer choice. Let's try 4. Y equals negative 3 times 4 minus 4. So y equals negative 12 minus 4. Well, that's going to give us negative 16, and that's not our coordinate right here. So automatically, D is out of the runnings. So C is our matching table of values to this rule. Okay, moving on to the third type of application, a very interesting application. So this says, which graph correctly displays 2 points represented by the equations? So here I have y equals 2x minus 1, and I want to know which one of these coordinate planes represent 2 coordinates that are on that rule. A couple ways you could do this. What we could do is we could find each of these coordinates here. We could say that A is negative 2, 3. And we could substitute our x value and our y value into our function. And we could do that to both coordinates. Another way we could do this is we could use our knowledge of slope-intercept form to figure out our graph. And I think you might like that method a little bit better. There's a little less arithmetic involved. Let me show you what I mean. So if I look at this rule here, we learned in the slope section that we have a slope and a y-intercept. So my slope in this case is 2. And my y-intercept is -1. So what I can do here is this. I can plot my first point at -1. Now, I have a slope of 2, which means if I had to break him into a rise and a run, I can break him into 2 over 1. So I would take him up 2 and over 1, up 2 over 1, and continue that pattern. But you can see that it's not going through those coordinates. Unlike, let's take a look at the second one. If I have a y-intercept of -1 and go up 2 over 1, I'm pretty close, but he's not quite going through both of those coordinates. My third one, I have a y-intercept of -1. I go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. And you can see that both coordinates are accounted for. Now, let's say you didn't like that method. Let me show you the other method you could have used, and let me use it with C, which we know is correct. I'm going to take this coordinate right here, and this coordinate is 0, -1. I'm going to plug in this x value and y value into our rule. So I'm going to say -1 is equal to 2 times my x value minus 1. -1 equals 0 minus 1. -1 equals -1. They work. This point is correct. Another way you could look at it, same type of idea. If we take our function y equals 2x minus 1, and we substitute the other value in, what value is that? That's 3, 5. I could do this. Y equals, I'm going to substitute my x value in. So y equals 6 minus 1. So y is equal to 5, which you can see it absolutely does. So either way you do this, C is going to be your correct option. So you can go the slope route or you can do the plugging in the numbers. Either one is fine. Okay, let's take another look at this one. Y equals 3x plus 2. Okay, so let's go the slope route. Our slope is 3, which we can break down into 3 over 1. And our y-intercept is 2. So I'm looking for a y-intercept of 2. Well, if you look at C, notice I have a y-intercept of 3. Automatically, he's out of the runnings. Okay, now let's look at A and B. All right, let's look at A first. I have a y-intercept of 2, and I have a slope of 3. So 1, 2, 3 over 1. And that would create a line that looks like this. So that doesn't work. But what about this one? If I said 1, 2, 3, notice that I'm not only going in the positive direction there, but I could also go in the negative direction, and it would go right through both of those coordinates. B is our final answer. All right, I have two more applications to look at. The first one is looking at a situation and matching up the correct table of values. So it says, Larry charges a customer a one-time fee of $15 plus $40 each week. Which table has values that represent the situation? So the first thing we want to do is talk about how to construct a problem that has something like this, a one-time fee. A one-time fee is a number that you are going to pay or you're going to do once. You're not going to do it, and it doesn't matter, how many weeks go by. It's a one-time fee. We like to say that that is going to be our y-intercept, our B. And then the other number is going to be our slope. So in our case, our y-intercept is 15, and then $40 each. That each represents that it's going to be changing depending on the weeks. That's going to be our slope. So if we were to construct an equation, it would look like y equals my slope of 40 times x plus our one-time fee of $15. Now that we have a rule, we can determine the possible table of values that it goes along with. So just like before, we can go ahead and figure out how it connects. So notice how I have 3 that's common in all of my table of values. Let's go ahead and substitute 3 into my equation. So y equals 40 times number of weeks is 3 plus 15. And if I do that, 40 times 3 is going to give me 120 plus 15. My y is going to give me 135. And the only option that has a corresponding y value is C. And therefore, C is our correct answer because A doesn't work, B doesn't work, and D doesn't work. Okay, let's try one more just like that. Mary is paid $50 a week for selling winter scarves at a booth in the mall. She's also paid $2 commission for every scarf she sells. Which table has values that represent the situation? So what we want to know is what is the flat fee, or what is the one-time fee, or what is the one-time number? And it looks like Mary's paid $50 a week. That is going to be the one-time fee. So that's going to be our B, our flat rate. The number that's changing is, well, she could sell 1 scarf, she could sell 2, she could sell 3. Depending on how many scarves she sells, well, that's going to be her commission. That's going to be the slope. So our equation is going to be y equals 2x plus 50, because she's going to make $50 a week no matter what. Now, all that really matters is how many scarves does she sell. She's going to make $2 on top of that $50 all the time. Okay, this one's a little harder because take a look at our x values. They're a little different. Personally, I like to go to the ones that are common. So I see that I have a 3 and I have a 3. But I can also see that both of those 3's correspond to 56. So it's not really going to tell me all that much. But let's see if there's anything else that's interesting. Well, let's go ahead and solve that. Why not? Let's go ahead and put a 3 in for my x. Y equals 2 times 3 plus 50. And that does give us 56. So we know that both of those check out nicely. Now from here, it's just going to require a little bit of work to figure out what is our table of values. So let's go ahead and figure out the 6 down here. So I'm going to say y equals 2 times 6 plus 50. So 2 times 6 is going to give me 12 plus 50, and that's going to give me 62, which is not the correct y value. So B is out. Let's go ahead and check out the other 7. I'm going to say y equals 2 times 7 plus 50. And 2 times 7 is 14 plus 50, and that does indeed give me 64. So it does look like that D is going to be my answer choice. But let's go ahead and see why A and C were not correct. Let's go ahead and try the 2 here. So I would say y equals 2 times 2 plus 50. So 2 times 2 is 4, and 4 plus 50 is going to give me 54, which is not our number. So A is out. C, let's go ahead and try, let's try the 1 there. So y equals 2 times 1 plus 50. That's going to give me 2 plus 50, which is going to give me 52, which is not our corresponding number. So C is out as well. So it does require some process of elimination to solve these problems, but you just need to know the method and the structure on how to set your problem up. So these are problems concerning application problems, and feel free to go back and look at this video at your leisure.